We don't do AI. We solve problems with AI.
It's a Lego block.
Yes,
that
it's
you put
not a
in,
standalone.
Yeah, that you put into your house that you build.
To start to use data to prove the concept is not an expensive exercise. By looking at data all the time, looking at these measurements, whenever these two things happen, we have a defect. And then I click. But you can predict quality defects by looking at process variables, and that's where the penny drops. We can't measure all those and find the correlations as humans, but the AI can do that. And that's when we made that decision to switch to artificial intelligence, and it's slowly migrating to the right. And that is how we were implementing more and more prescription, and the thing was learning. And for 3 months, we had 0 scrap in Detroit. I just said to myself, I want to be the best founder. I want to know everything about this industry. Is it 10,000 hours on a tar road or 10,000 hours on a dirt road? Makes a difference.
It makes a big difference.
Calm seas don't make good sailors. You're watching the train crash and you see that's going to happen, and you have to let it happen because that's where the learning will come.
Yeah, exactly. And that to let go of is not easy.
As soon as you start to unlock the team, you progress at a much higher rate because you've got multiple nodes of improvement happening all over the show.
Pieter du Plessis, the CEO of Atlantis Foundries. I had a fantastic conversation with him. We discussed everything from his ambition to wanting to be the best foundryman, all the way up to him being the CEO of Atlantis Foundries. How he's practically adopted AI in his factory to almost produce 0 defects in a foundry, which I found really fantastic. We also discussed a number of topics around leadership. We spoke about how the way you apply your 10,000 hours makes a difference. Learning your 10,000 hours on calm seas versus learning your 10,000 hours on choppy waters, very different. And towards the end of the podcast, Pieter fantastically did a presentation for us on the practical steps they took to actually adopt AI in the factory. As you can see, the podcast is really long. So we put timestamps at different sections so you can actually skip to the sections that you find most interesting. We really value your feedback. Please feel free to comment. All we ask is for you to like and subscribe and follow our podcast.
Pieter, thank you very much for having us. We are super excited. I have an opening question, and I want to open it like this. As a 23-year-old, 24-year-old young boy, did you ever imagine your life as a CEO of a big manufacturing company? I have a picture where you guys have Barack Obama looking at one of your products and looking at the adoption of AI at scale in the manufacturing industry. Did you ever see that would be your life today?
In my career, there's been ups and then 2 steps back and then going forward again. I personally never thought I would get here and do this job for this wonderful company. As a 23-year-old, I remember I read a book. It was an Afrikaans book. They translated it, and it was Dink soos 'n wenner, think like a winner. And it was all about positive thought and setting yourself a goal, and you will somehow achieve it. Your being will help you to get there. It's been a lot of hard work down the line, some fortunate events that happen. I still can't tell you how I got here. So yeah, it's a journey that takes you and eventually brings you here. It's difficult to describe to somebody else, this is the recipe, this is what you must do. I would say the thing that would have helped me the most was having the goal, and I had the goal to be the best foundryman. That was my goal. And then just the passion, doing it for that goal, for no other reason. I didn't do it for money or anything else. I just said to myself, I want to be the best foundryman. I want to know everything about this industry. And that's how I got where I am.
And what is Foundry? So someone like me who doesn't know anything about Foundry, what is that quick overview of?
So a foundry, if we take this engine block, which is now a scale version of that one, if you want this 3-dimensional object, okay, you have a few options. The first one is getting a solid block of steel and machining this out of that solid block of steel. That would be a possibility, but it would be very expensive because a lot of material would be lost. So what a foundry does is we take a 3-dimensional product, we make a sand mold, and we pour the liquid metal into that sand mold. The liquid metal solidifies, we break the casting out of the sand mold, and you end up with a casting. You can also do it with pressure die casting, where the mold or the form is a permanent form made of steel, and you inject aluminium, normally non-ferrous metals, into there. There's some lost foam processes, which are fascinating, growing turbine blades for jet engines and power stations. Our foundry uses sand molds, and we use cast iron to make a three-dimensional shape. So we get this 3D model from our customer, and we have to make it for them. And we have to make many of them every day. So it's a very old process as well, making molds from sand. The principle has been around since Foundry started thousands of years ago. The melting processes have recently changed to electrical melting, but the melting processes are very similar for many years. And it's an old technology, having to make modern products today. And that is one of the key things that led us to this journey. How do we use this old technology, these old philosophies, to make a very complicated product that's getting more and more sophisticated, more and more tight specifications. And that is the adaptation that we had to do. How to use the old and make something modern with it.
So here's a question that just kind of popped into my mind as you were talking. You have, in a technical environment, manufacturing environment, you have leaders that really have a deep understanding of the product, as you do. Yeah. And I'm pretty sure if we said, Pieter, go well, please give us more details, you'd be able to go really deep, because yes, as you say, your vision was to be the best foundryman. Yes. And that has led you to be the leader of this organization. Then you have leaders that are not product experts, but business experts. Yes. And I don't know which is better or worse. What's your take on that concept? Do you think that a manufacturing environment should have a person that really understands the product, or should actually understand business, or both? Or what's your take on that?
I think there's space for both of them. If you're in an environment like Atlantis Foundries, where we're part of a big corporate Daimler truck, with a lot of the big corporate systems in place and basically dictated from head office, this is how you will do your accounting and your cost accounting, and this is how we manage cash flow. These business principles are of lesser importance, because you're almost a production facility. And they're more the people management, and the product management is more important. If you were a standalone company, which we were for a while, then a lot more of the business things come to the front. I think for business people with say an accountant or a lawyer that has to run a business like a foundry, if they don't have a very strong technical team, it becomes very difficult. And I've seen that as well, where I've had bosses that in the past that were not foundrymen, and they struggled if the team is not strong enough, because they don't know how to correct the team, they don't know how to correct technical problems which are hampering you. And in our case, technical issues, because this is such a complicated product, dominates over business issues. I've worked in other companies where the business environment is more important, and the product is not so sophisticated and so problematic. So there's space for both, I believe.
I just, the reason why I asked the question was, in addition to what you were saying, was I was listening to a podcast on Steve Jobs versus Tim Cook. Steve Jobs was a product guy. He was probably the worst person to manage from a business perspective, but he was so focused on the product. And Tim Cook is probably the best guy from a business perspective. And like you said, I think you need, space for both. It's like you need both. There's no question about that. Have you faced the challenge where you've understood it technically, and I need to go in a certain direction to solve a technical problem, but financially it didn't make sense. And how do you resolve that?
So I've been lucky in that sense. My very first job was with Dr. Fritz Feichtinger, and he made me do cost accounting for the first 6 months of my life.
Okay.
And I never understood why. And he always said to me, if you don't know how to cost the thing, how can you make the thing? And then later on in life, I studied further after my engineering degree. So I've always had the philosophy that if you come with a technical solution, it must either be a cost-effective solution or it solves a safe and healthy health and safety problem, which there is no cost you can put to that. But sometimes, and with the AI, was one of the few cases where what is the payback? We don't know. We don't know what's going to happen. We're going to spend this money, and we don't know when the money is going to come back or if it's even going to come back. And then you have to take a bit of a leap of faith, but a calculated one, not just blindly jumping off the cliff. But it is difficult for production people sometimes to justify why I want this, and they can't make the financial justification, and then many projects die.
Yeah.
You speak about AI, and AI, the foundation of AI basically is data, right? And early on in your career, you were interested in data before it became the data that we know it as today.
Yes.
How could you see it that far? And of course, I'm asking this question in hindsight, looking at what it is, but early on, what intrigued you in that direction?
So in my early career, I was what they call a methods engineer. So I prescribed the method how to make these products. And in my very first foundry, we made once-off and two-off products. So every method was different all the time. And then I went to work for Murray & Roberts Foundries at Gearing's Foundry, which was in Epping, Cape Town. And that's all of a sudden a high-volume mass production facility. And we all know the City Golf. We used to make the safety critical components for the City Golf, so you can take no chances on these things. And the one problematic part was the brake drum. And we used to make these on a dieselmatic, and there was 2 on a plate, so you were making 400 an hour of these things. And then all of a sudden, you could have a lot of data. And we had a specific technical problem with the brake drum. And in the QC section, we did some dimensional checking. And I noticed every time we have this specific quality defect, this dimension was bigger. And I thought, this is interesting. So
Was this that by coincidence?
by coincidence, just by looking at data all the time, looking at these measurements, and we were pre-machining some of the brake drums as a quality control. And I noticed just, okay, these two things, whenever these two things happen, we have a defect. And that led me to go and look at the machine and try to understand how the machine is working. And I remember taking a vernier caliper and just sticking it across the mold. And as the thing was transporting, you could see the caliper opening and closing, opening and closing. And that was changing the dimensional variance on the part. And then I clicked, but you can predict quality defects by looking at process variables. And that's where the penny dropped. And once that penny had dropped, it's a rabbit hole. Then we started to link metallurgical parameters to quality defects. Where we're today looking at AI, we're busy remodeling our AI algorithm, and we've now put 196 variables in.
Wow.
We can't measure all those and find the correlations as humans, but the AI can do that. And that's where the data part came in. And I became obsessed with this kind of data. I remember making Excel sheets and wanting to type the data in myself, because just the act of typing the data in, you see trends in the numbers. Now it's automated and it's captured off the PLC directly, but that's how it started, typing things in Excel. It was actually Quattro Pro at the time, not even Excel. Excel came later. Yes.
Wow. And so obviously then there was let's say a second passion. There's the Foundryman vision, and then there was the data that you've kind of combined.
Yes.
Before you became responsible for an organization where you could make a leadership decision and say, we're going to do this, guys, how did you sort of try to get that in the organization that you're in, to use more data? Essentially, now it's easy to say it's data-driven decision making, right? So
yes.
You have your intuition, you have data, you put them together, and then you get a sort of better outcome.
So to start to use data to prove the concept is not an expensive exercise.
Yeah.
You literally just go out into your plant and you collect the data yourself. You measure something yourself and you put it in Excel spreadsheets or SPC charts, and you can demonstrate very cheaply that there's something to this just by going and doing it. Everybody also thinks about big data. That's a huge, big thing that you have to do. You can start very small. And using simple techniques, you can demonstrate already. And once you've demonstrated 3 or 4 times and you've shown the benefit, then it becomes an easy sell. Yeah. But you have to have that first case. And for this brake drum, when they picked up porosity on the brake drum, we scrap a batch, 1,500 castings in one shot. So you solve that problem, which was reoccurring and then nobody understood it, then all of a sudden people said, oh, there's something to this. Yeah. Yeah. And I think that is one of the key things that I've always done with data, and here in Atlantis Foundries as well, with problem solving and data. We don't do AI. We solve problems with AI. Yeah. We don't do AI for the sake of AI. We have a problem that we want to solve, and we tailor make our solutions to solving a problem.
I think that's a big misunderstanding with most people, is that I think they adopt buzzwords.
Yes.
You know, they have lots of buzzwords and they want to adopt it for the sake of adopting it.
Yes.
I think AI, the word, is going to dissolve, yes, and the use of it in your product or your solution is going to be very, very powerful. You've basically implemented a predictive quality system, yes, in your factory. Yes. Full stop.
Exactly.
It is enabled by lots of things,
yes,
including AI, but it's not AI.
And one of the foundations of it was actually many years ago, I was a quality manager at Atlantis Foundry, and we had to go over to QS 9000.
Okay,
you might remember that. And in there, they were starting to build these philosophies of a process with inputs and managing the process, and the output would be correct. Yeah. So that gelled very nicely with the use of data that we were doing already. Yeah. And you're correct. It is a buzzword now, AI, but it's just another tool for us.
Yeah, it's a Lego block.
Yes,
that
it's
you put
not a
in,
standalone.
Yeah, that you put into your, yes, house that you're building.
Exactly, it's not this standalone one tool. No.
I've been guilty of it myself. I've said we must implement AI. For what? And yes, you know, it's almost like, yes, we must implement the internet.
Yes.
You know, it's a tool you use for lots of things, but it's not a thing.
Yes.
You know.
There's a question that I have for both of you guys as leaders of organizations. It's and I want to lead to the conversation of, when did you realize you are becoming the CEO or assume a leadership position, right? And so when someone is really good at something, the natural evolution within an organization is to make that person a manager or a leader of a team. And sometimes those people actually do not possess those qualities to actually lead, right? And so as leaders, how do you navigate and know if someone actually even wants to be a leader or could be? And I'm asking that question to figure out, at what point were you an exceptionally good Foundryman, were fascinated with the process, and then now you had to become a leader of others?
I think the Foundry industry is guilty of that classical thing of the good technical guy becomes the boss.
Yeah, I don't think it's your industry. It's like every industry, including ours.
And that was for me one of the hardest transitions as well. To go from that extremely goal-orientated, pushing yourself and achieving things, to now pushing a team and thinking you can push this team as hard as you push yourself. and that doesn't work. And you have to adapt. I've adapted a lot. People that have known me for a long time say the Pieter of 10 years and 20 years ago is completely different today, because you adapt and you learn along the way. If the day you stop learning and adapting, that's it. That's the beginning of the end for you. So to transition from this hard personal goals, working with machines and product, to now inspiring teams, it doesn't happen overnight. I don't believe, I think there's a bit of personality in leadership, but for me, there's a lot of development with it. I would not say I was a good leader when I first had my first management job. Can't remember how long ago anymore. I wouldn't classify myself as being a good leader there. I was giving you results, but they were casualties.
At the expense of something, yeah?
Yes,
yeah.
They were casualties. And over time you realize that you will only progress as fast as you then. But as soon as you start to unlock the team, you progress at a much higher rate because you've got multiple nodes of improvement happening all over the show. And you just have to manage that and pull some back a little bit, because if one runs too far ahead of the rest, you lose the rest of the team, and that becomes your task. It's not easy. It doesn't come, there's no manual for it either, because we are all different people, and you must understand how people tick, and you have to start to understand body language and tone of voice.
Age groups.
Yeah, age groups as well. Yes, different. I mean, in Atlantis Foundries, our youngest managers are 29, and the oldest one is going to retire end of next year, and everything in between. Yeah. And they have different ways and means.
Yeah, leadership is I echo exactly what Pieter's saying. You can't put your finger on it. It's a thing that you often get cast into because of good work you did.
Yes.
Not as a leader, in a technical role, in my case, and in your case probably as well.
Yeah.
Then you get, oh, you're good technically, now you must be the boss.
Yes.
And then you, okay. I think in my case, the casualty was actually myself.
Okay.
So it was more like, okay, I was maybe more of a people pleaser, where I was wanting to make the team all comfortable, and that whole soft, fluffy situation at the expense of then me doing the work, too much work. So I think but again, as you say, you learn, evolve, and things change. And just when you think, okay, I've got a team, it's well-oiled, something happens, and then you got to adjust. And so I think I've become much more comfortable with the adjustment and continuous change in teams, external environment, internal environment. It's just, and also learning to let go in my case was just, okay, let's see what happens. I know there's going to be some blood on the dance floor at some point, but that blood is where people will learn. Blood is the wrong word, but the failures are where people are going to learn, right?
Yeah, I call it, you're watching the train crash, and you see that's going to happen, and you have to let it happen, because that's where the learning will come.
Yeah, exactly. And that to let go of is not easy.
No.
So I think the name of the guy is Malcolm Gladwell. I think he speaks about the 10,000 hours, right, in order for you to be good. So the guy who's technically really good has put in his hours, right? And then now, when you put in that many hours, how do you then have a balanced lifestyle as a CEO that keeps you human? Because then you can't stay in the factory all the time and be looking at the data profiles, and because then you're not going to have a life.
Yes. So I want to come to the 10,000 hours. Is it 10,000 hours on a tar road or 10,000 hours on a dirt road? It makes a difference. It
makes a big difference.
Calm seas don't make good sailors.
Yeah.
So
that's a good point.
The type of hours are important. Many failures, spectacular failures. I can remember them, where I failed, and that's how you learn. How to balance life, and what you do is you need to empower the team. So the things that I spark, I sometimes only see myself as the spark to let it start, and then it has to go by itself. And you have to trust other people that they are looking at it. And you start to look at, are people looking at what they're supposed to be looking at, and not looking at what they are supposed to be looking at.
Yeah.
there.
It's a subtle difference, but
It's
so
a subtle
important.
difference.
That's so important.
And yeah, sometimes you have to keep up to speed technically, because the Foundry is like a storybook. If you miss a chapter, you start to lose the storyline. So you sort of need to keep up abreast of what's happening in the process. And being able to say to people, okay, look at this as well. I don't think you're paying enough attention there. And that is what you do. You direct people where they should be looking. And you also have, as a CEO, different other tasks, which are thankless tasks that you have to do in the background. I always say to people, it's not fun being the CEO, because remember, all the problems that nobody else can solve arrives at your desk. And there are admin type things that you need to do. And so these things also consume your time, but it's extremely important to make time for yourself. I cycle, that's what I do. And if I can't train, then you feel the stress building. So you have to have something that is helping you to deal with the stresses and strains of the job. And for me, that's cycling. And if you don't balance what you have to do at work, there's no time for the cycling, and then it becomes a vicious circle. So you have to have this balance in life. And sleep is the most important thing. I'm a religious 8-hour-a-day sleeper. Don't cut on that. Then you also start to...
The spiral goes the wrong way.
Yes, yes.
Yanesh, in the 2 years that I've worked for him, has been, I don't think I've got it yet, grilling the idea of resilience and grit. And I was actually watching a conversation of VCs giving funding, and the guy was mentioning how once he's seen that you have a good idea, the next thing he looks at is this guy the guy that could actually get it done?
Yeah.
More than actually the other things. And how important is that for you as a CEO, resilience and grit, and in the people that you are inspiring now, that you have to spark that interest for?
It is 100% correct what you say. And these 10,000 hours, if they were on the highway, you have less grit and determination than the guy that did it on a dirt road. It doesn't make it easier, it just makes it easier to cope with. The pain and the difficulties are still there of the job, and sometimes having to push people hard to get something done and to know when to let off. And also choosing a team with grit as well, people that you see that can make things happen. There are people that just can't do that. I don't know why. I think it's maybe to do with passion and self-determination. But yeah, some people lack that ability to just make it happen, and other people just do it effortlessly.
It's if you can figure out the 2 or 3 questions I can ask in an interview to figure that out, I'll be very happy with that. Because you have 1 hour, 2 hours with a person. That's why we go through such a rigorous interview process. It's not about the content and the technical ability, which you obviously need to have, and you can check for that. But it's about the identifying the grit and the ability to actually have a team of people that can fight through the hard time, not through the tar road. Yes. We need people on the gravel road. Up in mountain, there's a bridge broken, and they need to get to the other side. Like, now what?
Yes.
That's what you need in a team. And if you're going to do amazing things, you're going to have to cross the river without a bridge.
Yes.
But how you do that and select a team is, I don't know, I haven't figured it out, but it's an important thing.
Yes. Yes. That is I would say one of the difficult parts of building a team is to find those people and to get them to work together. But once you've got that going, it's magic. Yeah. It's magic.
Yeah, that's a very interesting one. The thing that I want to get into is when we talk about Industry 4.0, the different technologies in it, when you look at the opportunities of AI, and I think people, when they think AI, and maybe I'm guilty of this as well, we think ChatGPT. But what are some of the the opportunities you see in the future of AI in manufacturing?
It's actually, I've played with ChatGPT a little bit as well, so there's obviously opportunity there. It's a very good lawyer. It gives you a starting point at least. For me, manufacturing is a continuous process of improving all the time, because it's a very competitive thing, especially automotive. There's always one guy doing it better, faster, cheaper. And that is where AI for me becomes another tool in your lean journey, in improving efficiencies, in improving quality. And that is where I see the biggest application. AI, yes, can design components and things like that, but we're not in that space. So in our manufacturing space of making castings is about making it better than the competition, faster than the competition, and cheaper than the competition. And this is where AI can help you with those, improving those efficiencies and squeezing out the last bit. In our journey to start to make this component, and we've been making it now since about 2006, this generation anyway. First, you start to apply the basic foundry principles and you get quality improvements. And then you start to look at process controls and you get quality improvements. And then you start to look at more sophisticated things like statistical process control. And then we got to certain improvements. And then we plateaued. We just couldn't get further. And we needed another tool. And AI was our tool to break us through the next barrier. So for me, as I said, it's not the magic bullet. You have to be through this journey, I think. You can't, if you want to run a marathon, this afternoon start with a 21-kilometer warm-up. It's not going to work.
I tried that the other day, it didn't work.
It didn't work. Fancy shoes with carbon soles, which is AI, is not going to work. It's going to be that last bit for you. You have to do the basics first to be able to apply the AI. Because if you can't control your process, AI is going to tell you what you must aim for. But if you can't control your process to that, you're lost. It is, as you say, it's a Lego block in your house.
I'm actually presenting tomorrow, and I presented 2 weeks ago on adoption of AI. And what my opening slide is basically the majority of people are trying to put a golden roof on a shack.
Yes.
So they want to use these buzz things, put these golden roofs, but your foundation is falling apart.
Yes.
You're wasting your time, all of your money. You got to build from the foundation, as Pieter said, the basics. You get all of that right first, and then you have the icing on the cake or the golden roof on a solid foundation. Then it makes sense.
Yes.
But if you try to just put it in for the sake of putting it in, if you can't make the effect the change, saying change this parameter from 4 to 5, and you can't change it from 4 to 5, what's the point in doing the AI?
Exactly.
And I think difficult. It's a simple concept to explain, but people want to get quick wins.
Yes.
And it's not a quick win.
No. No, definitely not. I've not seen a quick win ever. Yeah. It's hard work, and making sure, as you say, your foundation is built, and then that's the fancy running shoes.
Yeah.
You know, as I'm listening to you talk again, I'm thinking about this. Like for us young people, when we look at industry leaders, like the both of you, we have this idea, or maybe it's my own self-projection of it almost feels like the climate is incentivizing wanting to be an industry leader of some sort. But I'm listening to you talk and I'm like, why would anybody want to be in this position or assume this position? It's more hours, more stress, more pressure. Is there fulfillment in this kind of stuff?
At some point in time, it changes. And for me, where it changed in Atlantis is I saw this company, this community, the value of this company for the South African industry, and it becomes bigger than you. You are just an enabler to make this company survive and become better. At a point, it's not you anymore. It is my team. It is the employees of this company. It is the community that we work in. It's the South African industry that you give back to and help along, as we're doing today by doing this podcast. It becomes bigger than you. And then that gives the fulfillment. When you have to do the tough stuff as well, you know you're giving something for the future.
I also think that you have to add the passion to it.
Yeah.
So it's the passion that gives you the ability to do the 10,000 hours on the dirt road.
Yes.
If you're passionate about running, doing 10,000 hours on the dirt road on a bike doesn't make sense.
Yeah.
Because if you know, etc. I still can. I don't think I'll ever get tired of looking at a machine working.
Yes.
I don't know what it is. Can't tell you what it is, but it's especially those ones that have been painful to get working are the ones that are most satisfying. And so that's why at least for me, why I keep going at it and keep going and keep going. Plus the community side of it, that's a relatively new thing for me. There's a sense of responsibility for the people around within our organization, but not even beyond that, the sort of community around us, what it means for everyone if we're successful. So it's no longer just a personal success, it's a broader picture. As you know, as Pieter is extremely passionate about promoting technology out of Africa. Somehow that's a thing for me. Why I was in Chicago 2 weeks ago presenting about the realities of adopting AI on the factory in the US. Because I think that we have the ability, we have the skills, and for me that's an underlying driving thing to show that we can do it. Probably the best performing foundry in the world here, right?
Yes. So for us, the recognition came when our German colleagues from our German foundry came to learn from us about AI and how we implementing it and what our journey was. That was for the team here, absolute recognition that we can do it. We didn't have to copy. We are being copied. The Chinese actually say it's quite an honor to get copied.
So for example, that picture with Barack, right? Looking at the block. Let's assume that that's a coincidence of good work and hard work that has been done over the years, right? And so, but then the young, they are chasing that coincidence moment, which in reality, you first have to do the hard work. You don't aspire to have a president of the United States looking at a product that you've done with such passion. How do you tell that message to us who are still in the journey? Maybe we might not get there, but let's hope we do. That, dude, it's not about the coincidence. There's this part.
We take many students in the company. Every year we take students and they come and do their practical training here. And I've had this conversation quite a few times with students, and I normally look at the ones that are quite passionate and want to get things done. And you know the conversation is going to come, where it's going to come to your office, but these people are not listening to me, and why? You have to earn the stripes. It is just part of the game. You have to walk those hard miles. And if you follow in the footsteps of the rest, at some point in time you can create your own path. But you must demonstrate to the rest of your team that you are in, that you are in the same game as them, and you are willing to walk the same hard miles as them. And that reality comes very quickly to these young people that I've seen in our company. I can see them in front of my face now, coming to sit in front of my office and talking to me about that. And it's repeated quite a few times. And that's actually one of the things that I've picked up high flyers, because they get frustrated and then they come and talk to you. That's another thing. I'm going to talk to the boss because of my frustration. That shows a certain amount of courage, and that passion to do something has driven them to the frustration, and that's when you start to shape.
Yeah, that just reminded me of a couple of conversations I've had with a few people where they said, if only I was a supervisor or a manager, I'd be able to get it done. And I think that's a sign where not in your case, but in other people's cases, there's a lack of integration in the team. And I often recommend the book Leader Without a Title, where leaders are within a group.
Yes.
There's no hierarchy or supervisor or title or anything, but they're in that group and they're influencing things.
Yes.
And that's what you need to look for. That's the person that you then mold and they can eventually become the leader. But if you're a leader because you have a title, then you're not a leader.
Yes.
They're respecting the title, not you, if that
Yes.
makes sense.
Yes.
And so many people have said, if I would have done it better if I was the supervisor or the manager. I'm like, no, you wouldn't. You wouldn't.
Oh, that is so, it's like I'm not ready to understand that yet. Maybe it's so hard to understand how.
So for me, there's 3 parts to leadership. One is the title that's given to you, so people respect that title. There's that walking the hard miles, what you earn and what you've just said, the leadership that you take. Yeah. You'll be amazed if you take leadership how it's just given to you. People will just somehow freely give you that leadership role, although it's not an official one.
And then when it comes time to a promotion or a next level, it's easy. Like obviously, it must be that person.
Yeah.
Look at what they're doing,
Yeah.
as opposed to giving you the role first and then doing it. I think it should be the other way around. At least that's how I always felt when I was much more junior. Let me just get it done. Doesn't matter. I don't care how old or how experienced somebody is. I'm going to try and keep moving it forward. Then that frustration, I know that feeling. I was like extremely frustrated. Things are not moving, to the point where I got even written warnings because I was overly frustrated with people. But I think those are important signs. So I've got one last question, and then I think we should do the presentation. I think lots of industry leaders like yourself, well, not yourself, are battling with this adoption of new tech. I think we spoke a little bit about the buzzwords, and if you were speaking to a fellow plant head of a factory, wherever it is in the world, what advice would you give them to start? What direction would you give them? Because I think the majority of factories I've visited and approached they're grappling with this. They don't want to follow buzzwords. They just don't know what's the first steps.
Yes. So when it comes to the AI, there's been a lot of hype built around it. And these super models like ChatGPT, that is really the pinnacle of things. And it's actually far simpler than that. And educate yourself about what it really is. Watch a couple of YouTube videos. There's many of them that just explains to you how AI works on a principle level, some of them very technical level. And you'll realize that you can do it on your desktop. There's software now. I love Orange. All the engineers here know if you do a presentation on a problem you've solved and there's no Orange analysis in there, then it's like, oh, okay, well, did you really do it properly? And those are not expensive things to do. Orange is freeware off the internet. Statistical process control courses are cheap and bountiful. You can do it online. So just start with it small. And once you've seen the business case and you start to understand how this thing works, it will take off. As soon as those first successes are coming, it will take off. And this is a bit of a philosophy of Atlantis Foundries as well. And I speak to my boss a lot of times about it. We just start the journey. And then we sometimes stumble around a little bit and change course and direction, but we start. We don't spend a lot of time to plan things out to the nth detail and then start the project. We start and we plan as we go. So that would be my best advice. Just start with it. What is the problem that you want to solve? That is the starting point. Don't do AI for AI. What is the problem I want to solve? And what are the AI or statistical process control or data tools that I can use to solve this problem? And once you've solved that problem, it just starts snowballing.
Would you think, would you advise any of those leaders to go a little deeper into understanding statistical process control? What is a machine learning model? That kind of thing, because the majority of plant leaders are looking at output production, and they look at my worst acronym, OEE.
Yeah.
And then they judge their performance, and then they push from the top down, fix quality, fix availability, whatever it is. And then the details are left to the more, let's say, junior people.
Yes.
Would you flip that around?
We've done a bit of both. The spark was from me pushing the project. And recently it's been a lot of bottom up kind of things. And I think as a plant leader, I would start with myself to understand what this thing is and get a good not a perfect understanding, but a good understanding of the possibilities. And the use cases are plentiful. And then at that point in time, when you have a clear understanding of what AI actually really means, then you can start to ask other people to dig into specific topics and do specific things. But I think you need to have an understanding first of what is going on.
Yeah, perfect.
My closing question is, I'm imagining a time before the calculator was invented, how mathematicians that a period before the calculator used to pride themselves for actually making the calculations without the calculator. When the calculator was invented, all of the other mathematicians used the calculator, right? And the ones prior would have felt you guys are lazy and all of that stuff. When you look at AI and how it's going, the uses of ChatGPT, it feels to me like the upcoming younger guys, the 18, 16-year-olds now, for them, now they have to learn how to think more than actually doing the thinking, if I'm making sense. So I'm interested in how do you now, as a person who's been in the industry for set years, integrate and not feel like these guys are not getting it as the transition is happening and we are all learning together of these new technologies that are revolutionizing how businesses are run and how we live our lives?
I think it's a case of you can become effective sooner nowadays as a youngster, new into the industry, because you've got more tools at your disposal. But I don't think you can sidestep everything. Because if you don't know what 2 + 2 is in your head, when you put it in the calculator, it's going to say 4, but is it really 4?
Yeah. Or why is it 4?
Why is it 4? I think you need a certain amount of foundational knowledge. But with these tools, you can become so effective so much quicker than what we, as I said, we had Quattro Pro. That was the first thing. I remember in my first company that I worked for, there was a logbook where you ranked off a time slot to work on the computer. Okay, so you had Wednesday afternoon 2 till 4. That was your slot. Now I've got 2 computers in my office. But you still need to understand the underlying things. There's no shortcut. I just can't see how you can shortcut the thing and skip all this and just jump, as you say, to the golden roof. Yeah. It's not going to work.
Yeah, there's some foundational things.
Yeah.
What those foundational things are, I think we're still figuring out.
Yeah.
Because I think we're going to skip a lot of the foundational things and realize there's shortcomings, and then we're going to come back.
Yeah.
And then realize actually you should know 2 + 2.
Yes.
Before you just get ChatGPT. I don't think it's evolving. Right? I don't think we actually know.
Yeah.
What those foundational things are. But definitely there's some foundational things that I can't imagine it not being there. Even with the calculator or Excel or.
Yeah. I mean, I've played with ChatGPT myself to find out what is this thing. Just like kick the tire and see what is happening here. And you ask it questions where you know what's going on, to see what it's answering you. And then you can see some gaps. And if you don't have the underlying knowledge, you would just follow verbatim what this thing is saying.
Take it as absolute truth.
Yes, yes.
And that's the danger.
Yes,
Big danger.
yes.
Peter, thank you very much for having us. It's been such a pleasure.
Thank you very much.
Been awesome. Did we miss any questions that you would like actually us to ask you that would benefit you?
There were questions about the zero emissions.
Yeah, so I actually put that as an option because I didn't want to ask it if it's not
Yeah.
an answer you were comfortable with talking about. I mean, happy to obviously ask it.
So being part of Daimler, they're listed on the DAX. So ESG is top priority for them. And there's activist shareholders that are asking these questions. We actually had a question the other day in prospectus, page 73, paragraph 5B. This changed, what happened, and we had to give the answer. So shareholders are getting more aware of net zero and environmental friendly and social and governance. For instance, putting in a solar plant. It will be the biggest one after Ford.
Wow.
In Silverton.
Okay.
Their peak capacity will be higher than us, but we have more sun. So in a year, we will do more than that. So you might have seen the
CEO Foundry is a very power-hungry business. How do you move towards sort of net zero carbon neutrality, which is extremely difficult? I don't think there is a more difficult part of the supply chain than a foundry to actually solve. So maybe an unfair question, but
So as part of Daimler Truck, all our environmental statistics gets rolled up into their statistics. And because of shareholder pressure and community and pressure, we have to look at the environment. So we've got our targets to reduce our carbon footprint, amount of energy we use per component, water usage and waste usage. So as part of that, we have worked with energy partners to install a 10 megawatt solar power plant on our site. We've got some vacant areas where we can have 20,000 ground mounted solar panels, which will give us the 10 megawatt. We decided not to do it ourselves because we want to make castings. We don't want to run a 10 megawatt grid-tied solar plant. You can imagine the technology involved and the technicalities involved. It's just not our thing. Yeah. So we've got a 20-year contract with them where they will supply us 10 megawatts of solar power.
That's huge.
It is in peak power, smaller than the Ford plant, but because the Western Cape gets more sun than up in Tshwane, our annual output would be higher. It's phase 1 of 3 phases. We have to continue to reduce our carbon footprint. This installation will reduce our carbon footprint by 25%.
That's huge.
Yes, and unfortunately, the South African electricity market is not as well developed as the European ones, where you can buy green electricity and wheel it over the grid. We're just starting this with that as South African companies. There is first projects on the go, and we're looking at that at a later stage. But at the moment, we decided to have it on premises.
And you said that's phase 1. So phase 2 and 3 would take you to obviously 50, 60%.
Yes. So we're aiming to reduce our carbon footprint to 50% by implementing phase 2 and 3. We've got some buildings with roofs that need replacing. And as we will replace the roofs, we will immediately install solar panels on those roofs. At the moment, it didn't make sense to put a solar panel on a brand new roof, on an old roof, because it still needs to last for 20 years. So that would be our phase 2s and 3s. This building that we're sitting in will be a small one, where the building will basically go off-grid. So we have to invest in these things to reduce our carbon footprint.
Do you think that in the long term it would actually be cheaper for you to subscribe to this power provider on premise versus the conventional power?
So at the moment, it is cheaper than what we're getting our electricity from at the moment. So from day one, we will have a saving already. Okay. If we purchased, the saving would have been even better, but as we said, we didn't want to manage it. Yeah. So it is cheaper from day one for us. Wow. So we have a saving from
so it makes sense financially. It's not just it's not a burden.
No, it's no financial burden. Okay. Absolutely no financial burden. The wheeling of electricity is still more expensive. Yeah. So at the moment, if you were to wheel energy from a solar plant up in the Northern Cape or a wind farm in the Eastern Cape, it would be more expensive. So it's not economically viable, and it's also still subject to load shedding.
Oh yes, of course.
Yes.
That's interesting that it's actually cheaper. So I mean, would it be a potential business case to say to other potential customers that need casted blocks to say, listen, I am greener, I'm potentially cheaper, I've got more sun. So is there opportunity to use that as a leverage to secure more business?
Yes, for a foundry, it would definitely make sense, because energy is a big part of any foundry. It takes a lot of kilowatt hours to melt the metal. For us, we will sell back to the city as well, okay, a part of the electricity, because on a Sunday when we have no production, our idling is less than 10 megawatt. So we will wheel into the city network on Sunday. So there's a revenue stream coming in. Wow, yeah. And for foundries, of course, it would make your product cheaper, definitely. Definitely.
So AI plus solar panels might be your secret sauce into securing more business for the local factory, right?
AI, solar panels, best team that I've got in the world. It's an awesome team. That is the winning recipe for us.
Yeah. Hopefully somebody watches this and then says, I need my cylinder blocks cast there.
Yes. Okay, today I would like to show how we implemented artificial intelligence in Atlantis Foundries. As normal for us, it started with a problem. We supply a high-value product into the European and American market. And you can see here Barack Obama is inspecting one of the engines that's built from our engine block in Detroit Diesel. So from the engine block, you get to an engine, and the value add is enormous. And then from the engine, obviously you get to the Mercedes-Benz Actros or the Freightliner Cascadia, which is another huge jump in value add. So with the component that we supply, they are machined in Germany and in Detroit. And with a casting that's machined, about 10% of your rejects will only be detected after the machining process, because these are subsurface defects. You cannot see them from visual inspection. We wanted to reduce the amount of defects detected at our customer. One is the cost of the defect. Secondly is we've got a long supply chain to Detroit and to Germany. And if your pipeline is contaminated, you have lots of sorting action, which is more expensive than the actual defect. Yeah. So historically, we learned that you can predict the outcome of your product using data. But we got to a point where we were not able to improve any further. And we then decided to look at artificial intelligence as a tool. And just to rewind a little bit back, we've been using statistical process control for quite a few years. We called it stop, call, wait. Just for the operator, stop if it's out of spec, call a supervisor or an engineer and wait.
Okay.
Sort of
Stop, call,
describing
wait.
stop, call, wait. Sort of describing the action instead of calling it SPC. And then this is this crazy thing, very high engineering. So we just call it stop, call, wait. And we had these charts running, and we identified 22 parameters in the plant that were critical. We then
So how long do you think it took you to get to the 22 parameters? Because that's not an overnight thing either.
No. So it wasn't 21 to start off with. It again started with a problem. And our pouring furnace was where we realized most of the defects are happening. So we captured some basic process parameters at the pouring furnace, and we started to run with them. And I think in about a 3-4 year period, it grew to the 22. And at that point, we had sort of stagnated at the scrap rate internally and at the customer, but we couldn't get any lower. Interestingly, when Data Profit first took our data, they came back after 2 weeks and says, well, everything is in statistical control. And I said, yeah, we know that.
Yeah.
that we know. We skipped the following step where you could get multiple processes and capturing the data on PLCs. That is the next logical step in SPC. We skipped this step because we were still using a manual system. We then also realized that although one process is in control and the second one is in control, you can have different outcomes because there's an interrelationship between the two processes. And in some areas, we had identified these correlations between two processes and what is the ideal limit to be adjusted. But now imagine having 22. Yeah. The combinations become immense. And this is when we said, so what do we do? More and more data, more and more complexity. Do we get more quality engineers, more charts, or do we try artificial intelligence? And that's when we made that decision to switch to artificial intelligence. And we only looked at defects after machining at our customer. That's where we started. That was the goal at the time.
That was the problem you're trying to solve.
That was the problem.
Very simple, specific.
That's it. So what we did is we wanted to have the human in the loop. We didn't want a bells and whistles autonomous system. Yeah. We wanted to take baby steps. So we started off with collecting all our data into a central database. And in the beginning, we were literally running around with USB sticks on a Thursday, copying all the data and dumping it on a server. And Data Profit came and pulled the data on a Thursday. So it wasn't even live. And they would give us then a prediction to say these components would be defective. At the time, we then wouldn't ship them. And then we said, okay, what must be the process parameter not to make them scrap in the first place? And then they gave us these predictions. And they aggregated those results, and they gave us a report which you could give to a process engineer. And it says the highest weight for this week at 89% is this process parameter. Please go and look at it. So that's how we didn't cut the human out of the loop. Instead of the engineer trying to figure out which process is out of control or out of process by how much, he already gets that. He just needs to now fix it.
Yeah. They're not trying to identify the problem, they're just trying to solve the problem.
Exactly. So you cut out all that work that is laborious and sometimes impossible to get to because of these interrelationships. The algorithm was also learning continuously because every Thursday when you uploaded new data, you uploaded quality data and you uploaded process data. And obviously the algorithm told you to adjust something last week. Yeah. So that's how the thing was continuously learning all the time. And in one of the schematics which will follow, you can actually see the learning. You can actually visualize it. It was not intentional, and we saw it afterwards. Lastly, We tried to minimize the process changes by this report that only highlighted the top 10. We didn't have to adjust all the parameters, we only had to adjust the most important ones. The next slide, I will explain a little bit. You'll see two graphs running, before AI and after AI. So on the left-hand side, we gave the algorithm at first all our data for 2016. And each of the little dots you see happening on the screen is a component. If it's a cross, there's no defect. If there's a dot, it was defective. And you can see the scrap rate running here in 2016. The blue one is internal, and the second axis is the external defect.
So it's when your customer figured it out.
Yes.
Okay.
Yes. So once we got the prescriptions, and that was in February 2017, we started to implement them. And this is the graph here on the right-hand side. And you'll see how the scrap and rework is just reducing it over the year. Yeah. You'll also notice how, I call it the cloud, and the data scientists hate it if I call it the cloud, how the cloud is shifting.
So it's more concentrated, eh?
Yes, it's more concentrated. And you can see from the beginning of the year to the end of the year, it is shifting. You can see this is where it starts, and it's slowly migrating to the right. And that is how we were implementing more and more prescription, and the thing was learning and giving us new prescriptions. You'll see the external graph go down to 0 there.
Yeah.
And for 3 months, we had 0 scrap in Detroit. We thought the quality engineers were off sick, they didn't capture the data, all sorts of ideas, and it was really that we had no rejects.
Wow. So that was 1 year's worth of learning.
Yes.
And then you implemented at the beginning of 2017.
Yes.
And basically by August, you were almost down. You were basically down to 0 at the customer.
Yes. So the initial reduction you can see is quite sharp here in the beginning of the year, and then obviously.
And then it starts learning, right?
Yeah, then it starts learning. So the interesting thing is, we just gave them the data. It was for about 200,000 components. And out of the 200,000 components, unfortunately, they have to have matching data. They managed to match data for about 7,000 components. So
what do you mean by matching? So a component with the parameters, eh?
Yes. Yeah. Yes. So if 2 or 3 of the parameters are missing, you can't use that component for that algorithm. So say you've got 10 process variables, you must have one component with all 10 process variables.
That's the what I often tell people is the context of the data.
Yes.
So you can have lots of data,
yes,
but if it's not in context.
Exactly. Exactly. And our data, and this is one of the learnings, our data was based on historic, check every half an hour. Once a shift. And that's how we transitioned as well now to get more data. Check component number 1, check component number 5. Yeah. And everybody checks, right? Yes. Yeah. And getting more data. And this is the next slide. This is the most work actually in the whole process, is getting to this data warehouse where you've got matching data.
Yeah. That's the foundation.
Yes.
That's the foundation we're talking about.
Yes.
People are doing the part after this.
Yes.
But then if the foundation is not there, then.
That's it. And I always compare it to megapixels of photograph. So here where the data wasn't perfectly matched, we still got a picture, but it was a 1 megapixel picture. When you start to match your data better and you're getting more data, you're getting a 7 megapixel picture or a 10 megapixel picture. So start. Doesn't matter what your data is, you will find something in there. This is the dream, where we can predict the defects, maximize the yield, have surface detection of the surface defects, and having that loop closed. So predicting, prescribing, and a vision system. The biggest challenge so far, and I've spoken to Gendermark about it, is the vision system. That is what is difficult for us still to do, because the block is gray. This model is also now gray, but the block is gray. There's no contrast on it for a camera. As humans, we can see it, but a vision system to inspect just a monocolored component is difficult. Not easy at all. The learnings we've had was traceability. We all had traceability before, but to use it in an algorithm, you need to align your traceability for component number 1, component number 2, so you get better data. The accuracy of the data was critical, because if you feed incorrect data, that's it. Equipment capabilities is obviously you needed to get the data out of the machines and not running around with USB sticks. We had to update equipment, fiber optic cables, to get all the data live. Soon then bandwidth and storage becomes an issue. So we putting stuff in the cloud. Then the human things. People were anxious about this thing is going to replace us because of the hype of AI. Okay? But today people see it as a tool. It's a shortcut to get to the problem and knowing what to fix. And that, I must say, disappeared quite quickly once people saw what it really meant.
It's actually your calculator.
Yes.
Making it quicker for you to actually solve the problem.
Exactly. The models are only valid for the process that it's trained on. So you can't take my model and take it to Foundry B. It doesn't work. And if you change something fundamental in your process, you have to remodel. It's just basic rules. The other thing that we learned is proxy parameters, where when we were giving information to the algorithm, the pouring time, for instance, was too long. But the algorithm didn't tell us the pouring time was too long. It gave us an actuator value, because that was the root cause. So it jumps to the root cause, and sometimes that was abstract for us.
Yeah,
and we
understand it.
You don't understand why is this linear transducer value important. I can't think of it. And you learn those things over time. So it looks like a bum answer, but it's just you don't understand the answer yet.
So in that case, it was actuator time was obviously directly correlated to pouring time.
Yes.
But you just couldn't see the two.
Yes.
Because it just gave you the root, right?
Yes.
Okay.
Yes. So it really goes to the root of things. So we've also learned in our model, we call it declutter the model. So now we only give one of the two values. We don't give it two values. Yeah. It's like saying to the model the same thing twice. So we've decluttered the models a little bit. Then this is obviously an expensive solution because there's Python coding and networks and things like that. And my all-time favorite is orange analysis. Okay, you can do it on your desktop. It runs off your Mac or your Android. It's freeware. You can go and download, and it's drag and drop. You have to have a basic understanding of statistics and AI models, and you can start building your own models. There's tutorials running. What I always say is, when you start playing with it, play with data that you know the answer for, and build your models. And this is extremely valuable, and we use it a lot when we've got small problems that happens. Our engineers would use Orange to do an analysis on new data without having to adjust the big algorithm, because the big algorithm, unfortunately, at the moment is still built for subsurface defects. We haven't built it for this new defect that's starting here tomorrow. It will give us an answer, including this defect, but if I want to isolate that defect, that's where we still need to work on. So that is our journey with AI. It's a tool, it's not a magic bullet, and as you said, the foundation needs to be there.
Two questions. Do you know of anyone else, maybe not necessarily foundries, but just in terms of manufacturing, adopting AI like this? Because this is not surface level stuff.
Yes.
This is foundational stuff?
Yes, I do.
Okay.
There's Sakti in Portugal.
Okay.
They very advanced as well.
Are they
They're
Foundry?
a foundry,
Okay.
they're a Diesematic foundry. I still want to go there. So hopefully if you see the podcast, invite me. But no, yes, it is being adopted. Our plant in Germany has started with an AI model as well for their cylinder heads. I know other foundries are using it in Brazil as well. So it is starting to spread in the industry. I also know of industries outside of the foundries that are adopting it. So I think the business cases are there and the use cases are being seen. And if you don't do it, you're going to get left behind.
I think that, I think the World Economic Forum and or Deloitte's call it lighthouse factories.
Yes.
They have these lighthouse factories around the world. I think you're one of the few lighthouse factories actually in the world. That because you're not just doing it as a pilot.
No.
This is running your business. This has had a direct impact on your performance from the customer's perspective.
Yes.
Which is massive. I mean, I am yet to see a plant adopted at its foundation, not just as a golden roof.
Yeah.
Second question I've got is, if you were to build a foundry again,
Yes.
greenfields,
Yes.
how would you do it different knowing what you know now? Both maybe from a data perspective and a mechanical, electrical, physics perspective.
So from what we've learned from the data and what processes are critical, I would definitely make different investment decisions in certain equipment. Pouring is, for instance, what we've seen one of the most critical processes. So I would buy the best automated pouring control system money can buy, because it will save you money. I would put the infrastructure and the databases in place to capture all of this data immediately, rather than wanting to retrofit it, because it becomes difficult. I think the equipment manufacturers in the industry, they all have different control systems, communication protocols, which we are adapting to. It would be great if there's some sort of standardization, and it would make it easier for companies to get plug-and-play solutions, because a lot of the money in developing the system is actually extracting that data from that machine out of that database, or interrogating a PLC, converting it and putting it in your SQL database. That's a lot of the coding is just around that. The AI models themselves are to a lesser extent time consuming. It's that getting the data.
I would, the last couple of presentations I've done in terms of advice to other manufacturers is you have to start with the data structure
Yes.
almost first.
Yes.
So I think that even beyond just the communication protocol is to say that if I have a certain process and I have, say 5 vendors, machine vendors, that are going to form part of this overall process, vendor number 1, this is the data
Yes.
I need.
Yes.
Before you even quote, are you agreeing to give me this data structure on whatever protocol you want? I mean, the protocol just needs to be fixed.
Yes.
There's many of them, but it's the data structure which then forms part of your big data model. And actually your IP sits in the data model now.
Yes.
So that actually is the real value and the differentiator. Yes, you still need to buy the machines and to cast the blocks, obviously. But the big differentiator is you now have an established data model, which has taken you a couple of years to get to.
Exactly. So you need to know how your data structure must be for the model. And exactly what you say. Supplier A, this is the stuff I want from you. Supplier B, C. And it's actually in our technical specifications now for new equipment that is what we want from you. We want this data out of there. Not all the suppliers are so happy to do it because they believe some of their IP is sitting in there. Yeah. But so far we've been successful with all our equipment suppliers to retro do it. And in future, as we're buying equipment, it becomes sort of automatic.
It's almost like how you specify I want a Siemens PLC.
Yes, exactly.
If a vendor doesn't want to use a Siemens PLC, then they're off the list.
Exactly.
It's got to get to that point.
Yeah.
Eventually, the PLC is going to be irrelevant because you just want the data model. You want the machine to work reliably, of course. Then you want the data model, and you want it to be passed in this time sequence, etc., etc. So I think that organizations, factories that can establish that data structure, data model, communication, the ones that do that first will be the winners.
Yes.
And especially with new projects going forward, as opposed to buying a line and then thinking about the data.
Yeah.
Because then it becomes extremely expensive.
Exactly, and it's too late there.
Yeah.
The other thing which I forgot to say, which becomes more and more critical, is data security.
Yeah.
Because you can't keep all of this data on premises. It has to go into the cloud, and you have to use cloud computing. So protecting your data from intrusion becomes very critical, and we've had to put some very sophisticated systems in place. We've got an AI monitoring our network for any unusual traffic. If I were to give you a password of Atlantis Foundries now, it will pick up that your device is new and will actually block you. So you have to do these things. Unfortunately, there are people that want your data.
Yeah. For sure. I also think that, I mean, you've implemented the Holy Grail here. It's almost prescriptive, almost. Yes, the human is making the change, but it's still prescriptive at the end of the day. I think there is opportunities for simple, as you spoke about, anomaly detectors. So if you have, you probably have, I don't know, 500 processes or maybe more.
6,500.
6,500 processes
points, yes.
That are running continuously. Not all of them are relevant to the model,
yes,
I'm sure. But those ones are still potentially important. So
Yes.
I mean, simple anomaly detectors are good examples that you can just run. They're the early warnings to say, listen, this process, it may not be affecting your quality, but it seems to be drifting or something.
So I'll give you one clue. I've shared freely with you what we've done 6 years ago.
Yes.
Imagine what we're doing today.
Good point. Point taken. Exactly. I can only imagine.
Yes.